Hello, welcome to CR4 News' very first Periscope broadcast. Today we will be broadcasting a 3D printer in action, printing a replica of the NASA Space Wrench. NASA emailed the design to the International Space Station Commander Barry Wilmore, who then printed the ratcheting socket wrench on an onboard 3D printer. This is the first ever tool emailed to space and printed in orbit. Just a little bit about CR4. CR4 Conference Room 4 at cr4.globalspec.com is a forum for engineers, scientists, students, and technically minded people to discuss engineering topics and get answers to engineering related questions. CR4 is an engineering community website supported by Engineering 360, one of the world's largest source for engineering news, information, and analysis. Dan, say hello to Dan, is an engineer with Engineering 360, and he's going to guide us through the additive manufacturing process and try to answer any questions you may have. So take it away, Dan.
All right. I'm just going to give a brief description, I guess. This is a fused filament type 3D printer. It is in this case which I built, which just keeps the heat in and keeps any particles from escaping, hopefully, or at least helps with that. I purchased the printer. It's not a home-built printer, but there have been some modifications to it, which I'm not going to go through, but there have been modifications made to it to help improve it some. You probably saw him sitting here. This is what we're attempting to print, although I guess I'm going to do it in black. I've actually had a fair number of problems printing this, and probably will have problems printing it today, to be honest. So it comes out. You can see the mechanism on this one. It actually does ratchet, it spins. I've had the ratchet mechanism part, I've had some issues with. Here are some failed examples where I started where like a piece came off here and got stuck, and you can see what it looks like. But hopefully it'll work for us well enough today. It's a learning experience for me, so you know, it's never going to be perfect, but that's the fun of it. So I'm going to get it started.
Great.
And I have this connected to the computer. I can start it on the printer, but I usually start it here just because it's easier, and I have the file uploaded here. And I'm just going to hit play here. And so the printer should get going in a second. It's going to make sure it's up to temperature, which will happen in a few seconds actually. And then it'll start printing and hopefully start printing successfully.
What is this module on the left here?
So this is the actual control and power supply for the printer that has all the electronics in it for it, and it's actually printing off the SD card, which is located right here. So the computer could be turned off at this point, and it would still continue to print. So right now it's homing itself, you know, making sure it's in the right location. Actually, I guess it already did that. So now it's spit out some filament to get started, just to make sure it's clear, and it's going to start laying down the first layer, which it sort of outlines it first and then starts printing inside of it.
Now, can you talk about what filament you're using?
Sure. The filament that I'm using today is PLA. I can print in ABS. I have printed it successfully stuff in ABS with this. PLA is a little bit easier to print with, especially if you want finer detail, which this has for the ratcheting mechanism and stuff. So I've chosen to use that for the demonstration purposes. the problem with ABS is as it cools, it tends to curl and it lifts and doesn't stick as well, where PLA tends to stick easier to the printing platform. The platform it's printing on is a glass plate, and the blue underneath it that you're seeing is a thermal pad to help conduct the heat because it's a heated plate. And I've used hairspray on top of the plate to help it stick, to adhere. It's a common thing, either that or the blue painter's tape is another common addition you put underneath it to help it stick. And I leveled the plate to try, and you want to make the plate, the printing platform, as level to the printing head as you can. And I mean, everything needs to be squared up, but I tried to make it as square as I can. And actually, if you notice in this enclosure, there's turnbuckles here and up here and stuff like that, which helps hold everything steady in here, which was one of the reasons I built the enclosure.
So you built this enclosure yourself?
Yeah. There's lots of enclosures that people have done. There's for this printer is based on the Persa i3, but it's a commercial version that's been adapted to somewhat, and there's lots of enclosures that would fit it, that would that are for the Persa. Some people have used IKEA furniture to modify it, but this is just my own with a steel frame.
So we have a question on how long does it take to print something like this?
This particular print is about a 2-hour print. There's a lot of factors that go into how long it takes. The layer height is one. This is a 0.2 in terms of the layer height. It has to do with how fine the layers are. So I don't know if this is going to see it. Maybe the black will be better. This has, you can see that there's like layers in here, that there's different, you can kind of see the fineness of it. Mm-hmm. Whereas some of the other ones that I've done, this one is an example, this is the 0.1 millimeter layer height, so it's a finer resolution. So this would take, if I printed at the higher resolution, it would take double the time. And some things need that higher resolution and some things don't. Unless I really need it, I tend to lower it, just because 4 hours to print this would be, 2 hours is enough, 4 hours is even more. There are other ways to speed it up. I could actually increase the printing speed a little bit and have things move faster in there, but it also ends up being more prone to errors when you do that, so I've not.
What type of maintenance do you have to do on the printer over time?
Not too much. I mean, I oil things occasionally, like these the rods. Sometimes you put oil on. You really don't want to go crazy with that. I haven't really had much maintenance. I mean, I haven't had well, I've printed a fair number of stuff, but I really haven't had much maintenance to it overall, other than initial changes and things like that at the beginning. But so far, I mean, I'm sure that there are things that'll wear out over time, I guess, bearings and belts maybe, but none of that's happened. I suppose at some point, when the big stuff starts wearing out, then it's probably just time for a new printer. I don't know. There's some things that are probably not worth replacing.
Sure.
Depends upon what goes wrong.
And what would one of these printers run for, dollar-wise?
Without the enclosure, and I don't have a dollar amount on the enclosure, but without the enclosure, about $400 for this one.
Okay.
I got it for a little less because it was early. It was introductory and it was early, so I got it for a little less than that. But I think that's around $400 at the moment.
And what's the lowest range and maybe the highest range?
This is close. I mean, there are printers that are different than this that you can get for $100. I don't know how good they are. I haven't played with them. Highest range is anything. I mean, it could be
like industrial.
Yeah, industrial would be the cost of a car or more.
Now, in terms of the story of the ratchet itself, do you have any background on that?
I don't know for sure. I mean, my understanding is that the 3D printer in space, first they printed a lot of things back on Earth, mostly tensile, for tensile strength kind of testing stuff. And then the idea was to print them in space and then bring them back down and compare the two to see if they compared favorably. So to know if 3D printing in space was the same. I don't believe the wrench was originally part of that. I don't know for sure. My understanding is they needed a wrench for something, although I don't know if it was actually used or not in space as a, for its purpose as a wrench. But they decided to just email it up, and so the astronaut could print it out for whatever purpose.
Yeah, that was some of the research I did was similar to that they planned 3D printing experiments. I think they first printed a nameplate, maybe. But then there was a need for a socket wrench, so they emailed the design. But it never indicated if they actually used it or not. So
I don't know.
So I'm not
and
sure.
I guess I'll point out one thing, which a lot of people ask me about the socket wrench. This has this internal moving part in it, but this is all printed as one thing. There's no assembly. It comes out like this. You do have to sort of break it free to free it up to spin, but that's it. There's no assembly of it. It's not two parts. It's all printed as one. I mean, it's two parts, but it's all printed as one. Actually, I had this before. This is also a single print, and you can see that this rotates. And so basically, it's just printed flat like this with small spaces between these, and then as long as you break it free, it and depending upon how materials and whatnot, depends upon how hard it is to break free. Sometimes they're really easy.
Another question from online, have you tried to see if the wrench works? Like, have you used the wrench yourself?
Not as a wrench. I mean, it does. I've played with this one, and it does lock. It ratchets in one direction and not the other. If you force it too hard, you can push it back, but it locks. I'm just holding it by hand, and then this direction it spins. So, but I've never tried to actually torque something down.
Does it have a torque rating?
Well, it has on it 3 inch-pounds. Oh, okay. This is written on it. Now, the original one that they did at NASA was done out of ABS. So this one is PLA. PLA tends to be more brittle, so that may impact what its actual ratings are. ABS has more flexibility in it, so it tends to be it withstands a little more strength because it'll flex instead of just breaking. And I'm looking for this to mess up if it's going to. When this is messed up in the past, the piece of plastic comes off of the printing bed, and if I leave it in there, it gets caught up in the print like it did in this one here and gets messed up. If I can grab it out of there before it does that, then usually it's okay, and it continues printing, and it doesn't. The part that comes out is not. It's missing a small part, but it's not critical. It ends up being like right here. You see that this is not flush, and that's all that happens. But it still prints the ratchet mechanism okay.
Now, how do you get designs? And do you have to pay for them? Or are they free? Or?
Some of them are pay, and some of them are free. I've gone to Thingiverse, which is MakerBot's site, and there's lots of free designs. There are other free sites. There's a lot of different free sites, although that one's the most popular. NASA actually had this one right up on their site. You could download it directly from them. It's called Uplink. And then there's sites that you pay for designs, and then you can design your own. I've done, for example, Tinkercad. I've designed my own things or modified things, and it's not too difficult to do. So there's all sorts of.
I remember you mentioned 3D.
The 3D scanning. So another thing that I've done is I've used
scan over to
an Xbox Kinect sensor, and if you're careful, you can scan yourself in. So, for example, here's a bust of myself. Here's a bust of myself that I did from a scan in of that. So, and that wasn't too hard to do. You just scanned it in, and so you can. There's all different ways of getting designs in. There's even ways of using a phone to take in a 3D scan. I've not done that, but I've played with it. And so you can see it's building up layer by layer here, taking this filament, which basically looks like weed whip cord, and melting it through a little tiny nozzle. You can see actually a piece of the string, or the melted stuff there. Actually, I have some that probably put out in the trash. here's like when it comes out, you get this kind of
Oh, so it's kind of trims it down.
it makes it really small, and it's spitting this out as this thin layer that's melting on top of the next layer, and it's building that up layer by layer to build the print.
Now, is there a cooling off period, like once it completes? Does it have to
So you
cool
can take
down,
it out,
or
not really.
how hot does it get?
The
plastic?
The plastic, as it comes out of the nozzle for PLA, is around 200 degrees. Right now it says it's 205. I have it set, 210 is about the top, and I have it set around there right now. ABS is print usually around like the 240 range, 245. But it cools down. There's a cooling fan blowing on the print as it's printing, so it cools the layer before it. So by the time it's done printing, it's cool enough to just reach in there and take it out. If you let it sit and cool down, the plastic shrinks a little bit, and it makes it easier to take off the bed because it will almost free itself. But that's usually not a problem, freeing it up.
So that border around, does it use that to help guide itself, or is it just initial?
No, that's just initial.
like
Honestly, I don't even know why it does that. It's just in the software that generates the code. But it does, if there's anything like, you see at the very beginning of that border, there's nothing there. So it just sort of clears the nozzle and makes sure it's ready to print. So it does help with that.
So we have a question online. What is it making? What are you making?
So we're making, I guess you just joined us, we're making this wrench. We're doing it in black like this one. But we're making this wrench, which is the design that NASA had sent to the space station. And trying to see if that piece is still there. It's working okay at the moment, I think. Oh, no, it came out. So I'm going to reach in there and get it as soon as I can.
Oh, so
the piece came out, which I kind of expected it would. Yeah. I'm not surprised, but I knew it wasn't going to be perfect. I've never gotten this to print 100% perfect for me. So I'm going to wait till it starts doing the handle. I'm going to see if I can reach in there and get it from the back here. Oh, it must have knocked it somewhere else. Oh, it's on the nozzle. Oh, I can't get it now, it's on the nozzle. Maybe it'll free up later. Oh, there it is.
So the ridges that it's putting in there, what is that? Is that just reinforcement?
Yeah, there's an internal structure that it builds. It's not just solid. And there's actually choices when you take the design. It doesn't come with this determined. You actually choose that as a percentage and then choose the pattern. So this is just parallel, just squares that it's printing inside. So it's not completely filled, because if you do it as a completely filled object, it would take much more plastic and take a lot longer. So there's other patterns like honeycomb patterns and other more interesting patterns. I just defaulted to the square pattern. I believe NASA actually did it with a honeycomb pattern, which I could have done too. You can see the beginnings of that on this one actually, where it's starting to print that internal pattern. So it's not solid inside.
Okay. How much of the filament does it use for printing this?
I'm not sure. It doesn't really, it doesn't take a whole ton of filament, but I'm not sure exactly how many feet it would use. I've never measured it. Actually, the printer does have it does log like how much filament it's pulled through it, but I've not checked that. There probably is a way to find out exactly how much filament goes through.
Now, is there a way to do multicolor project?
There is, not with the way I have it set up now, but there is. Well, you could do it with the way it's set up now, I guess. You can actually pause a print and change out a filament and then restart it. So you could pause it, change out to a different color filament and restart it. And then the only other way that I know, well, there's other printers that have multiple heads. And so you can put in multiple colors or materials. This was a single head printer. And then there's a device that I believe it's called the palette, and it will take, I think, 4 filaments, and it will fuse them together into a single filament with the multiple colors, and it will measure. So they change that fuses them in the way that, so that they change at the right positions, and then it measures how much filament is going through the machine and knows when it's reached the appropriate point to change out. And actually, it goes off and spits off a little bit at the transition, so you don't have so the color is a sharp transition. I think you can open up the doors if you want. Yeah, kind of smells like anything almost.
Now, is there like food? I've read about that. Like you can, edible ones, I guess.
That's debatable. There are probably some certified printers, but the printer would have to be certified for that, and I don't believe that they are. PLA would be the choice to go, and there are natural PLAs which would not have any coloring added to it. It would be the natural filament, and there are ones that are food safe PLA, but in the process of going through the printer, they come into contact with all sorts of things. So I wouldn't say any of them are really food safe that you're going to print. And then there are coatings you can coat on them after and stuff like that. But once again, I'm still not. I mean, one of the key things is, for example, the nozzle. A lot of nozzles, they have brass, and so the brass has the metals of the brass. Could potentially, you could have some come off and join with the metal. My nozzle is actually, I changed it out, so it's actually a stainless steel and aluminum nozzle. And there is actually, I believe, some brass, but it's coated with some special coating, plated actually. So that never comes into contact with the filament, but I still wouldn't consider it food safe, even if I got a filament that was food safe.
Now, there are medical applications.
There are medical applications. One of the recent ones is, the simplest one, I guess, is to practice a surgery. So you could print out the internals or replicas of the internals of the body part, and then the doctors can use that to practice.
Now, how do they do like an MRI?
I believe so. They do an MRI scan. Just so you know, we're printing the space wrencher in black, so this one will hold up, I guess. So far, it seems to be working out okay. This is the design that NASA sent to the space shuttle. I thought it would be a good first print to demonstrate it, and it has some neat functions in the sense that it has moving parts internal to it. We're just printing it out. This print should take about 2 hours total, and hopefully it'll turn out okay. I'm going to point out while we're paused there, not paused, but while we're waiting, I actually have some 3D printed parts on the printer itself that I've printed out with the printer to enhance the printer since I purchased it. So, for example, I'm going to open up the door here. These round knobs here, with numbers on them.
Oh, so you printed these?
I printed those.
And those as part of your...
Yeah, and those are in ABS. So I printed those, and they're now part of the printer. And they make it easier to adjust. Those adjust the leveling of the bed. On the control box, this stops button is also part of the print. Something I printed out. And then actually, if you notice that this front plate is angled, when I first got this printer, this front plate was flat, and I printed out this part here that angles it out, so it's easier to use.
So do people make? Did you make the design yourself, or did
No,
people make those
people
as
made
part
the
of the
design.
maker community?
Yes, people made the design and posted it as something for this printer. And there's other things for this printer as well that people have designed. Actually, another one I printed out is the back plate on this box I printed as well. That one, I actually, somebody shared that and I modified it to my taste. So I took their design, modified it a little bit, and made it. Are you sure we're live? Because this is still showing.
Yeah, that's it.
Oh, okay, I see. That's all right. Do you want me to hold that?
No, I can focus. So I think we were talking when I put up the medical.
Oh yeah,
No.
that they use it to experiment or to practice the surgery before they do it. That's my understanding, that they'll print out replicas of the organs, and that way they, you know, if you're getting in there, you know how things feel, as opposed to just if you can't see it, to make sure you can do it, and that way you can practice it a bunch of times before you really do it. There is 3D printing where you print actual body or framework for body parts, but I believe that's still I don't know enough about that. It's still in its infancy. I know of, there's something where I heard that they use it for like burns, to print in a burn wound like a lattice structure to help the skin grow over it.
Oh.
But I don't know that much about that.
Now, what are some of these that you have on top of the printer?
So these are some of my past prints that I've done. This was actually I think one of the first prints, just a little octopus thing. This is a cat. This is the lattice sort of structure has names this guy Veronal, or I don't know how to pronounce it, Veroni. No, I'm pronouncing it wrong. Verac. I don't know. I have to look it up. It starts with a V. And I have this. Actually, this was one of my first prints too. Was this hand?
Oh.
That actually, the octopus and the hand, the printer came with those files already, so they were there, and the filament that I used to print this came with the printer too, before I bought any. And then I was showing you before this thing I have, which is just these sort of gyroscopic rings that they're printed all together in turn. You know, they don't come apart. You can't take that out. It was printed that way. This is actually a block that had IHS and shadow, and this is an emoticon thing. And the bust of myself, and somebody asked me to print this car, which I guess needs to be glued together, printed as separate parts. It's a Porsche. I did. My wife gave some of them as gifts to people. I had like a little vase with flowers in it. What else did I do? She sent me a list of things to print that she wanted to give people. The flowers was the neatest one of them. Boy, I don't remember what penguin. One of them was a penguin, and I don't remember the other one. There were only 3 things that she sent me. Yeah, you know, makes little gifts. I mean, I think right now, because 3D printing is still relatively new, getting something that's 3D printed is still sort of, it's neat that, you know, it's unusual, so it still makes a neat gift.
Do we have any questions from the viewers out there on the internet?
I'll add, since you're talking about holiday gifts, one thing that may come up is cost. And I can't speak to the cost of running the machine because I don't know how well it's going to last, but in terms of material costs, a spool is about 2.2 pounds is about around $20, depending upon where you get it and the type of material, but around $20. And for stuff like this, it you know, it's got to be, you know, a few cents, honestly, probably easily less than $1 worth of material. If this doesn't use that much. I guess you could weigh them out if you wanted to see, but since they're hollow, and actually here's some failed prints I had when you can see the hollow. You actually choose the hollowness as a percentage, so that determines the size of these, so you can see the different size internal structure of them as an example. And this one is this is 20% fill. You choose the percentage of fill, and then also how thick the walls are going to be around it and things like that. That's not part of the design when you download a design or come up with a design. That's specific when you print it. Yeah, part of the settings. It's called the slicer. So you load the design into a slicer software, and it slices it into layers and generates the code that tells the machine where to move and what to do. And so the machine is just reading a bunch of, you know, direction movement, you know, movement, move here, move there, and part of that is spitting out filament. So the slicer takes in your CAD design and turns it into that list of coordinated movements for the machine.
So how far along would you say this is?
It's 20%.
Oh, it indicates right here.
It's on the screen too, actually. So you have an idea of how far along it's going to be. And actually, if I'm printing this off of the SD card, you can print it directly from the computer. I tend not to do that because if the computer decides to reboot on me or install an update, it could mess things up. But if you print it off the computer, it'll actually give you an ETA instead of a percentage, and it'll, you know, say ending in 1 hour and, you know, 30 minutes or something like that.
And we're now at 88% complete, and just wanted to show you the progress that we've made so far. So you can see it's taken shape and is a lot thicker than it was when we left before. So Dan, do you want to?
Yeah, it's starting to print the top layer now with the lettering in it. And one of the things I guess about PLA, about the material I'm printing this in, is it melts at a much lower temperature. So while this will work, you don't want to leave it in a hot part because you'll end up with a melted piece. But otherwise, it looks okay.
And what was the material?
PLA, polylactic acid, I believe. I think so.
And then you said other materials like ABS.
ABS, actually, I have some in here, so I'll pull out. This is where I have all my materials, and I keep them. You want to keep the materials dry, so I have, for example, this dryer dehumidifier in it. And within the boxes of the materials, they come with they come in bags, and they come with this, these drying things, and I'll leave them in there and store them in here to try and keep them dry. But I have PETG, which I actually haven't printed with yet, but I have some here. Yeah. There's different brands, and they have different qualities. This one's blue, and this one down here is yellow. And then this is black ABS, and then this is gray ABS in this box.
Is the ABS more expensive?
No, it's the same price.
Oh, really?
Yeah, it's the exact same price for the most part. They have, what do I have in this one? This one is this is PLA, but this one's glow in the dark. I haven't used it yet, so it's still sealed. And they have flexible ones. You can make like wristbands and stuff like that with it, but I don't have any of that. lots of different materials.
Now, why would you use ABS over what you're using now?
So ABS is harder to print with because of the heat. Let me just come over here so because the ABS is harder to print with because of the heat required, and you need it tends to curl as it cools down. So it doesn't stick as well to the printing plate. So there's a little more difficulty in that, but it's more durable. It's a little more flexible, so it doesn't break as easily. Where this is more brittle, and then it won't melt as easy. So if you had it in the sun, where this may melt, the ABS wouldn't. So for different, certain applications, it's desirable. And the other thing I didn't talk about in the materials is their support materials. So this is a single head printer, but if you have a dual head printer or more, you can put in, for example, support materials. So you could print something that was completely free floating, and then you print the support material in the space, and then the support material gets dissolved out by either water or limonene as a chemical. You just soak it. You can do, even in these, you can do supports. I don't have anything with a support in it, but like in this, I had a support that printed like this. And it prints a support that just is not well connected, and you just break it off at the end. This doesn't have any supports on it, so I can't show you that, but there are ways to add supports into the structure. It just depends upon where anything, the printer can print. So if you start printing from a flat base, if you go past, if you want to print like this, you can see it angles out like this on the bottom. If you angle out past 45 degrees, the printer usually has difficulty with that. And so if you did that and you had to print, if I wanted to print this like that, I would have to have support underneath this to hold it. Maybe that might work because that's 45 degrees, but that wouldn't, And as long as you're within 45 degrees, it'll usually print. Like this wave thing didn't need a support, but if it was straight out or something like that, it might have needed more, needed support. This didn't need any support because of the way that these printed. You can orient, you can shift around the way that the print is laying down, so that you can try and avoid using supports. It's better if you don't use them, but sometimes you need them.
So now it looks like it's doing the lettering? Or?
Yeah, it's doing the lettering on the top. It has to do it layer by layer, so yeah.
3-inch panels?
Yeah, and then I guess the other thing I didn't talk about is on this one, you see this base here, which is sitting on. This base is actually not part of the print. Here, I got one here too. Let me use this one because I'm going to pull this one off. They call this a raft. I try not to use them, but this design came, preloaded, and this one had a problem here. But so this raft here and is actually designed to break off when you're done printing and give you the smooth bottom. It helps it. This is to help it stick. So sometimes you put a raft like this, and so the raft will stick and it avoids some problems, but you end up using extra plastic.
Now, does it print the raft for you?
Yes, it prints the raft for you.
First, yeah.
It prints that first. It's all part of
Part
it.
of the design.
This has no raft. And then the other thing is a brim. And a brim, I don't have an example of it because it comes off, but a brim would be, it prints it flat, but it prints it a thin layer around it. So it's like the base has a thin layer that helps it adhere, that just keeps it locked down. But I didn't print that. This is just, if you can avoid using the brim and the raft, you try and avoid using them so you don't waste materials and have waste to throw out. When I do ABS prints though, ABS dissolves in acetone, and so what I'll do is I have a jar, and I'll take the scraps from the ABS and I'll throw them in the jar with acetone, and you get like a ABS glue, and I'll use that to help to spread on the printing plate, and it helps bond the ABS print. So then I just continually throw my scrap in that thing.
What's the print nozzle made of?
This one is it's coated. I don't remember the coating, but you know what?
I guess are there different ones too?
Yeah, this is the nozzle that's in there is a nozzle that I bought an all metal nozzle for. I'm searching here. It is. This is actually the nozzle that came with the printer. I changed it out, so the one I have in there now looks a little different. That's actually they call it the hot end. So the nozzle is here, and you know, so that's where your material is coming out of. The one that's in there now has brass, but it has plating on it, so, and I forget what it's plated with. There's a special plating, and so then the one I have in there now, this piece of plastic is not in there. There's no plastic, so it allows you to go higher in temperature, because the problem is the plastic will start to melt if you really go up there, and it allows things to flow through easier and more range of materials. So, but basically your filament is going through here, through this hole here, and it's getting heated up here on this part. You actually want to keep this part cool, which is why there's the fan on the side of the print head there. You want to keep this part cool on the top so the plastic doesn't melt until it gets into the nozzle, and then the nozzle part is hot. And it's also changing the nozzle allowed me to print faster, although I'm not utilizing it now, but it would, with this nozzle there were some problems. If you tried to print too fast, it didn't work well where that nozzle was a little better. I mean, they have their own characteristics. They're not, you know, it's just a matter of what you prefer and what you want to do with the printer.
Yeah, so it looks like we're at 95%. So getting,
yeah, it's going to
you
start.
see the control panel here. What are the different, so it's just showing XYZ coordinates?
Yeah, it's showing the coordinates as it's going through, and so this top one is the temperature of the nozzle. So it's set at 210, and you see it's using a PID control to try and keep it around there, but it's bouncing up and down. And then this is the temperature of the printing plate. So
in Fahrenheit or
in Celsius.
in Celsius?
And then it's just telling you how much is complete and the coordinates as they're going by.
96?
Yeah, and I use...
Oh, so now it's building. What would you call the end piece here?
What's the name of it? The part that it links that the socket goes onto. I'm sure there's a name for it. Yeah.
Looks like it's doing that now.
And I'm using, I'll point to it but not touch it. Well, I guess I won't. The SD card that I'm using in this.
Oh, you want to?
Yeah, the SD card that I'm using in this is the Wi-Fi, so I can upload the files to it through a Wi-Fi link. So you can upload it through the printer, but it takes a long time because it's actually converted to serial, you know, RS-232 serial, and so it's very slow to upload to it. So
Hi, there's a question about what we're printing. So we're printing the NASA space wrench. It's a socket wrench that was emailed to the space station, and they printed it on their onboard 3D printer.
Yep, and you can see some examples of a finished one right here. We're printing it in black. This is one I printed the other day. It actually didn't work out so well. Sometimes you have various failures. There's actually, I don't think you can see it, but this must have come undone from the plate. It must have unstuck, and so it warped it here, and so I can't free this one up. Whereas this one is free and spins. And that one I couldn't get free. Maybe it'll come free, but I didn't want to force it too hard. This one seems to be going okay. Sometimes you have little things, it doesn't adhere correctly, you know, or for whatever reason.
So it looks like it's done with the handle, though.
Yeah, it's done with the handle. It's just doing that shaft there for the socket, and we can snap it off once it's finished. And I can try and free it up, although sometimes you have to put a little bit of force on it, and I don't have anything with me to twist it with. It's usually not just totally free at the first, you know, time. If I had something to grip it with, I could probably free it up. But yeah, it's almost done, 97%. And
it's going fast now.
Yeah, once it gets to the end, there's only a little bit for it to do. It doesn't have to move all over.
So the part that is that considered an XY table?
The table in the bottom is the Z direction is the up and down. This one only moves it, you know, the left right is on that on that, on that axis, and then this just moves back and forth.
Oh, so that's only moving in one direction.
Yeah,
Then the head moves the other.
Yes, exactly.
Yeah.
So the head has two directions, and then the base has one direction.
Oh, that makes sense.
There's different designs. This is the Persa, named after the guy who designed, came up with this setup. But there are ones that move the base in all directions. There's ones that move the nozzle in all directions, and then combination in between. It's just a matter of that particular design, what made sense. And there's, one of the problems you have is if there's any vibration, anything like has springiness in it, that will mess up your print because it's very quickly going back and forth. And so if it doesn't stop dead at the right spot, if there's a ringing in it, you'll see that in the print in various things. And some of my prints have some elements of that in it, and there's things that I've done to tighten it up, and there's still some things I could do to tighten it up even more actually that I haven't done yet. But that's, is still, there's some printers out there that are, I guess, much more expensive and a little more fine-tuned, but for the money I thought this one was pretty good.
And you would think as time goes, this is still relatively new technology.
Yeah, I'm sure.
So as time goes on, they're going to get better and more economical.
Absolutely. It's nice to be able to print out these small parts when you're... Yeah,
we're at 99% right now. Now, can you modify a design, customize it? Say, do you want to put your name on it?
Some of them are actually designed to be customized to put your name on it, but you can customize any of them. You can import the files and modify them. I've done that with various designs for whatever I wanted to suit my needs, so it's done now. Just going to move it out of the way, and I'll reach in there and grab it. And actually, I'm gonna go over to the computer here so I can bring that forwards. Yeah. So I'm going to bring the printing plate forwards here.
Oh, so you're doing that with the computer?
Yeah, I'm doing that with the computer, so I can. So now it's just easier to grab. And let's see if it snaps off of here. I'm going to grab I'm glad it stuck well though.
Yeah.
I'll just grab this and there we go.
Wow.
Pull this off so I don't have this left on the plate.
So there we have it, a finished NASA space wrench printed. Now, what was the time? Does it show the elapsed time?
It doesn't show the elapsed time, and I don't see if I can free this up. But
it's about 2 hours.
Yeah, it's about 2 hours.
We started around 1:30, so.
Yeah, I can't free it up by hand. If I had pliers or something, I could free it up. But
this one works.
Yeah, this one you can see works. It's just a matter of freeing it up.
Yeah.
But yeah,
so cool.
it's sometimes you can push on it a little bit, and probably as it's still warm, as it cools down, it'll get more brittle, and then it'll be easier to break it, because right now it still has some flexibility.
Yeah.
So that's what it looks like.
All right. Well, again, want to thank Dan for taking the time to show us the 3D printer, and thank everyone that joined us on our maiden voyage of Periscope for CR4 News. Please visit CR4. Zoom in on the URL here, cr4.globalspec.com. Please check us out, and we'll be doing more of these broadcasts as time goes on, and should be some neat stuff and fun stuff. So please follow us, and we'll see everybody soon. Take care.